Welcome to the new session of the differential equation. In this module, we will discuss about method of the variation of parameters and the Euler-Cauchy equation. We already discussed about the method of the variation of parameters, and in this session we will discuss how the method of variation of parameters for the non-homogeneous equation will use in Euler-Cauchy equation. We already discussed about the Euler-Cauchy equation. See, here we have second order linear non-homogeneous differential equation y double dash plus p of x y dash plus q of x y is equal to r of x. See, here p of x comma q of x and r of x are functions of x alone, or the constants, or maybe that they are the constants or the constant values constants. See, this is the standard form of the second order linear non-homogeneous differential equation. See, this differential equation has general solution as y is equal to yh plus yp. Y is equal to yh plus yp. This is the solution. Yh is the complementary function, that is the solution of the corresponding homogeneous equation, that is the corresponding homogeneous differential equation. See, dear friends, here we have another function, that is yp. The yp is actually a particular solution, that is the particular solution is a special solution will exist for this differential equation 1, will exist for this differential equation 1, and we can find that particular solution by using the formula yp is equal to minus y1 into integral of y2 of r, y2 into r divided by w, the Wronskian, into dx, plus y2 into integral y1 into r divided by w dx. See, here we have y1 and y2 are here. This y1 and y2 are the solution, independent basis solution of homogeneous equation. That is, they are the solutions of the homogeneous equation y double dash plus p of x y dash plus q of x y is equal to 0. See, y1, y2 are the basis of this homogeneous equation. See, here we have one more thing is that is the Wronskian. What is actually the Wronskian? Wronskian is, we can find by using the formula Wronskian is equal to, that is determinant of y1, y2 and y1 dash, y2 dash. See, dear students, we can calculate this one, that is y1 dash and y2 dash, this is y2 dash. So, we can calculate this as y1 into y2 dash, y1 into y2 dash minus y2 into y1 dash, y2 into y1 dash. See, we can calculate the determinant value by using this formula. So, we will have the Wronskian that may be constant or function of x alone. Since y1 and y2 are functions of x alone or the constants, so we can have this is equal to, this may be function of x alone or a constant, and we can apply this all things to this formula. So, we have y1, y2 that we will get from yh, and if also we can find this is r of x already given here in our this question, this is r of x is here, that is actually r, and one more thing is here, it is Wronskian, that can be found by using the formula, the determinant formula, that is y1 y2 dash and minus y2 y1 dash is there. See, in this session we will discuss about how can we will use this method of variation of parameters in Euler-Cauchy equation. So, we already discussed how can we evaluate the Euler-Cauchy equation, how can we find the general solution of the Euler-Cauchy equation, that we already discussed before. See, what is actually Euler-Cauchy equation? We know that the Euler-Cauchy equation is of the form x square y double dash plus p of x y dash plus q of x y is equal to 0. See, if in the case of that Euler-Cauchy equation, we can find the general formula by general solution by finding the auxiliary equation. Actually the auxiliary equation is m square plus a minus 1, that is instead of a minus 1, here instead of p of x there may be the constant or function will be there. In the case of constant coefficient, this is a y dash plus b y is equal to 0. So, on that case we will apply a minus 1 into m plus b is equal to 0. From here we will have 3 solutions, from here we can find 2 values for m, that may be we call it as m1 and m2. That m1 and m2 may be they are real, they have 3 choices for this m1 and m2, because the auxiliary equation is quadratic equation. As because that is the quadratic equation, this may be real and distinct, this may be real and distinct, okay. That may be real and distinct or may be real and equal, that is double root, real and equal root may be real and equal root, or maybe finally the have another choice is that the root may be complex conjugate, that roots may be complex conjugate. I will not discuss more about it, this already we discussed in previous session about the Euler solutions of the Euler-Cauchy equation. So, my dear students, our thought is that how can we solve a non-homogeneous linear differential equation whose homogeneous part is as Euler-Cauchy equation, and by using the method of variation of parameters. Okay, fine, we can move to a problem. Solve the non-homogeneous Euler-Cauchy differential equation, the non-homogeneous Euler-Cauchy differential equation, the non-homogeneous Euler-Cauchy differential equation x square y double dash minus 4xy dash and plus 6y is equal to 21x raised to minus 4. This is our equation 1, 21x raised to minus 4 by method of variation of parameters by MVP. So, my dear students, we have to solve this non-homogeneous Euler-Cauchy differential equation, that is x square y double dash plus 4x minus 4xy dash plus 6y is equal to 21x raised to minus 4. See, while solving this aspect of solution, firstly we will write the corresponding homogeneous equation. We have the general solution is actually the general solution of equation number 1 is actually y is equal to yh plus yp, y is equal to yh plus yp. See, we already discussed about what is yh. Yh is a complementary function, that is the solution of the homogeneous equation, and yp is the particular solution. We already demonstrated the formula to find yp. So, to find yh, we are considering this first part is the corresponding homogeneous equation. Homogeneous differential equation is, the corresponding homogeneous differential equation is actually x square y double dash minus 4xy dash plus 6y is equal to 0. X square y double dash minus 4xy dash plus 6y is equal to 0 is the corresponding homogeneous equation. Okay, fine. Here the value of A, this is actually the value of A is actually, A is here minus 4, and here we have the value of B is 6. Okay, the value of A is actually minus 4. So, value of B is equal to 6. So, dear students, we can use the auxiliary equation to find the general solution. The auxiliary equation is m square plus a minus 1 into m plus b is equal to 0. Okay, fine. Here we have m square plus a minus 1, the value of a is equal to minus 4 plus minus 4 minus 1 into m plus 6, the value of b is equal to 6. So, actually the auxiliary equation is m square minus 5m plus 6 equal to 0. Okay, we can factorize, that is while multiplying 2 and 3, we will have the value is equal to 6, and while adding the values 2 plus 3 is equal to 5. So, we have to get the coefficient of m as minus 5, therefore, we will add minus 2 plus, we will add minus 2 plus minus 3. Okay, we will add minus 2 plus minus 3. Okay, therefore, we will have minus 2 into minus 3, that is minus 2 into minus 3 is actually 6. So, we have the we can factorize this as m minus 2 into m minus 3 is equal to 0, m minus 2 into m minus 3 is equal to 0, that is m is equal to m1 is equal to 2 and m2 is equal to 3, fine. Now, we found the auxiliary equation, the roots of the auxiliary equation. The roots of the auxiliary equations are actually 2 and 3, they are real and distinct. Therefore, YH is equal to, YH is actually C1, we already discussed, x raised to m1 plus C2 x raised to m2. Fine. So, we found this is YH is equal to, this is C1 into x raised to m1, x raised to m1 is there, x square plus C2 x raised to m2, that is x cube. Fine. So, we found here, from here we will have C, from here we will have the value is equal to, this is x square is our y1 and x cube is our y2, they will form the basis for the differential equation. So, this is our homogeneous equation. From there we have y1 is equal to x square or y2 is equal to x cube is there. So, we have to find the yp. To find yp, we have the solution formula. To find yp, we have the formula. To find yp, we have the formula yp is equal to minus y1 into integral of y2 r divided by w the Wronskian dx plus y2 into integral of y1 r divided by Wronskian dx is there. y2 into y1 r into Wronskian dx is there. So, dear students, here we will have the value of minus y1, y1 is actually x square, y2 is x cube. Therefore, we will have this is equal to y1 is equal to, that is minus x square into integral of y2 is actually x cube into r of x. We have the r of x from our question, we will have the r of x as this is equal to 21, x raised to minus 4 is actually r of x. Okay. Therefore, 21 x raised to minus 4 is there. So, we will have the r of x is equal to 21 x raised to minus 4 divided by, we have to find the Wronskian. Okay. We did not find the Wronskian, so we have to find the Wronskian dx plus y2 into integral of y1. So, y2 is actually x cube into integral of x square into r of x, that is 21 x raised to minus 4 divided by, we need to find Wronskian for here also. So, we have to find the Wronskian. We have the formula, the Wronskian is actually W is equal to modulus determinant of y1, y2, y1 dash, y2 dash is there. That is equal to determinant of, that is y1 is x square, y2 is x cube and y1 dash is 2x and y2 dash is 3x square. See dear students, we can multiply x square into 3x square, that is equal to 3 x raised to 4 minus, we will have this is equal to, and 2x into x cube, that is actually 2x into x cube is x raised to 4 into 2, therefore, minus 2x raised to 4. So, we found actually the value is equal to 3x raised to 3x raised to 4 minus 2x raised to 4, that the value is actually x raised to 4. Therefore, we found the value of Wronskian is actually the x raised to 4 is the Wronskian, that we can apply here. Here we have W is here, we will just apply here. So, we found the solution of the homogeneous part as YH is equal to C1 x square plus C2 x cube. So, here we have y1 as x square and y2 as x cube is there. Now, we need to find the yp, the particular solution. See, here we have given differential equation as x square y double dash minus 4xy dash plus 6y is equal to 21x raised to minus 4. We have to standardize the differential equation with the first term as y double dash alone to apply the variable method of variation of parameters. So, see here we divide the entire equation with x square, therefore, we will have x square y double dash divided by x square as y double dash minus 4x divided by x square, that is equal to minus 4 by x into y dash plus 6 divided by x square into y is equal to 21 x raised to minus 4 divided by x square, therefore, 21 x raised to minus 6 is there. The second equation is very equivalent differential equation of the equation 1. Okay, fine. So, we have r of x as 21 x raised to minus 6. So, we redefined r of x as 21 x raised to minus 6 as r of x. We redefined r of x as 21 x raised to minus 6. So, dear friends, now we found the r of x, we already found this one, we already found y1 and y2. So, we have to apply, we have to find the solution for the differential equation by using to find yp. We can find yp as yp is equal to minus y1 into integral y2 into r of x divided by Wronskian into dx plus y plus y2 into integral of y1 into r of y1 into r of x divided by w dx is here. W dx is here. So, we can apply all those things. We know y1 and y2, we already found r of x from here. So, we have to find the Wronskian. The Wronskian is actually w is equal to y1, y2, y1 dash and y2 dash is there. So, y1 is x square, y2 is x cube, y1 dash is 2x, y2 dash is 3x square. Therefore, we will have 3x raised to 4 minus 2x raised to 4 is there, 3x raised to 4 minus 2x raised to 4 is actually x raised to 4 is there. So, we found Wronskian as x raised to 4. So, we can apply in this equation, So, we will have the equation as yp is equal to minus y1 minus x square into the y2 is x cube into r of x is actually 21 x raised to minus 6. Okay, 21 x raised to minus 6 divided by the Wronskian. We found the Wronskian as x raised to minus 4. So, sorry, x raised to 4. So, we have the Wronskian is equal to x raised to 4 into dx plus y2 is x cube into integral of y1. y1 is equal to x square into r of x is 21 x raised to minus 6 divided by x raised to 4 dx. Okay, fine. So, we will have this is equal to minus x square into integral of, we have x cube is here. So, we can cancel this and this, finally, we will have 1 is here, or also here x square is there, here x raised to 4 is there, we will have x square is there in denominator, here x is there, therefore, integral of 21 x raised to minus 6 plus minus 1, that is x raised to minus 7 dx plus x cube into integral of, we will take this plus 2 to here, therefore, we will have minus 2, minus 6 minus 2 is minus 8, therefore, x cube into integral of 21 x raised to minus 8 dx. Okay, fine. Here we have minus x square, this is equal to minus x square into integral of 21 x raised to minus 7 minus x raised to minus 7 plus 1 divided by minus 7 plus 1. So, x raised to 21 into x raised to minus 7 plus 1 divided by minus 7 plus 1, plus, see again x cube is there, 21 into x raised to minus 8, x raised to minus 8 plus 1 divided by minus 8 plus 1, x cube into x raised to 21 into x raised to minus 8 plus 1 divided by minus 8 plus 1. Okay, therefore, we will have this is equal to minus x square into 21 divided by minus 6 into x raised to minus 7 plus 1 is minus 6 plus x cube into 21 divided by minus 7, okay, x raised to minus 8 plus 1 is x raised to minus 7 is here. See, dear students, we will have here, that is minus and minus will be positive, therefore, finally, minus and minus is here, they are positive, therefore, we will make it positive, therefore, x square into x raised to minus 6, 21 divided by 6 into x raised to minus 4 is here. Okay. And here we will have minus 21 divided by 7 into x raised to minus 7 plus 3, therefore, x raised to minus 4 is here. Okay. So, finally, we found the x raised to minus 4 is here, x raised to minus 4 into 21 divided by 6 minus 21 divided by 7. Okay. So, finally, we will have x raised to minus 4 into 7 into 21. So, we will have 147 minus 6 into 21, that is equal to 126 divided by 6 into 7, 42. Okay. 7 into 21 is 147 and 6 into 21 is 120 plus 6, 126 here we will have this is equal to 126, okay, divided by 6 into 7, that is equal to 42. Okay, fine. So, we will have x raised to minus 4, this is equal to x raised to minus 4 into finally 147 divided minus 126. 126 is actually the value is equal to 126 plus 20 is equal to 146 plus 147, that is 21. The value is equal to 21 divided by the denominator is equal to 42. So, 42. Therefore, the value is equal to 1 by 2 x raised to minus 4. The actual value is equal to 1 by 2 x raised to minus 4 we will have. This is actually yp. See my dear students, now we found yp. Okay, we have yp, so we need to find out y, that is the general solution. Therefore, we have the general solution of the given, therefore, general solution of given non-homogeneous Euler Cauchy differential equation is y is equal to yh plus yp. We already found yh as y is equal to c1 x square plus c2 x cube, and finally, we found yp as 1 by 2 x raised to minus 4. So, finally, the yp is here. So, we can write yp as 1 by 2 x raised to minus 4. So, this is the general solution of the given non-homogeneous differential equation. Okay. So, we are happy with it. We got a solution of this differential equation. See, dear friends, actually what we did here it is that here we have a differential equation, that is the non-homogeneous linear differential equation. See, x square y double dash minus 4xy dash plus xy is equal to 21x raised to minus 4. That is second order non-homogeneous differential equation. While considering whose general solution is actually yh plus yp, where yh is the solution of the homogeneous part. Okay, while considering whose homogeneous part, we understood that is actually this one, that is actually Euler Cauchy homogeneous, second order Euler Cauchy homogeneous linear differential equation. So, we applied the auxiliary equation. While applying auxiliary equation, we got the roots of the auxiliary equation. After getting the roots of the auxiliary equation, we understood it is that the roots are real and distinct. Therefore, we will have the general solution as of the form y is equal to c1 x raised to m1 plus c2 x raised to m2 plus is equal, that is y is equal to c1 x square plus c2 x square. So, we understood that the basis of homogeneous solution are y1 is equal to x square and y2 is equal to x cube. See, we have formula to find this one x square y double dash minus 4xy dash plus 6y is equal to 21x raised to minus 4 is our differential equation. So, to find yp, we just try to convert that is into standard form. So, we have to make the first term as the term containing y double dash alone. For that, we just divided entire term with y, x square. So, we got this as, and the r of x is changed into 21x raised to minus 6. So, we have the formula to find this one, and yp is equal to minus y1 into integral of y2 into r of x divided by Wronskian into dx plus y2 into integral of y1 into r of x divided by Wronskian into dx. So, here we know the y1 is x square and y2 is x cube. The Wronskian, the r of x is 21x raised to minus 6 is there. So, actually we need to find out the Wronskian. So, while evaluating, we understood that the Wronskian is actually x raised to 4 is here. we just apply all these values and we manipulating the equation. So, finally, we arrived the solution as the yp is equal to 1 by 2 x raised to minus 4. So, we have the general solution is actually yh plus yp, general solution is actually yh plus yp. So, we have y is equal to c1 x square plus c2 x cube plus 1 by 2 x raised to minus 4. See, there are many problems are available in the literature of the differential equation that can be solved by using the method of the variation of the parameter. By using MVP, we can solve that equation. I am providing some assignment questions to you. Assignment questions. So, solve the following questions. Solve the following non-homogeneous Euler Cauchy differential equation by using method of variation of parameters. I would like to write the first question as w, so that is x square y double dash minus xy dash is equal to 3 plus x into x cube e raised to x, 3 plus x into x cube e raised to x. Okay. See, while seeing this question, we understood it is that we can find this is equal to homogeneous equation as x square y double dash minus xy dash is equal to 0. See, while evaluating this one, the a is equal to minus 1, and we will have the auxiliary equation as m square minus 1 minus 1 minus 2m. The term b is equal to 0, therefore, this is equal to 0. So, we will have this implies we will have the m into m minus 2 equal to 0. So, we found m is equal to 0 and m is equal to 2 are the roots of auxiliary equation. So, the roots are real and distinct. Therefore, the yh, the solution of the homogeneous part is c1 x raised to 0, that is c1 itself, c2 x square is there. So, c1 plus c2 x square is the solution. Therefore, y1 is equal to 1 and y2 is equal to x square is there. So, we are able to find out, we will get the linearly independent basis for the homogeneous parts. So, we can find the Wronskian and we can divide the entire term, we can divide the entire term with a x square to make it standard form of the non-homogeneous equation to apply the method of variation of parameters. Dear students, we just divide the entire term with the x square. While dividing the entire equation with x square, we will have the equation as y double dash minus 1 by xy dash is equal to, while dividing x with x square, finally we will have this is equal to 3 plus x into, we divide x cube divided by x square. So, finally we will have x e raised to x is there, x e raised to x is there. So, this is the new equation. This is a new equation with the p of x, with the r of x, p of x is minus 1 by x, and with r of x as the relevant term is r of x. So, we redefined r of x. By using this r of x and the y1 and y2 that we found from here as 1 and x square is there, y1 and y2, and the r of x is there, and we can find the Wronskian from this y1 and y2, and we just apply into the so formula of the yp, we will get the general solution of this differential equation. This is the hint to this differential to solve this differential equation. So, I am providing one more question to you to solve. Okay, write down the next question as the same. We have to solve this non-homogeneous, this one non-homogeneous Euler Cauchy differential equation by using MVP, that is actually x square d square, x square d square, where d square is d square by dx square plus minus 2xd plus 2 into y is equal to minus 2xd plus 2 into y is equal to x cube cos x, See, my dear students, here we will have this, this is actually x square y double dash minus 2xy dash plus 2y is equal to x cube into cos x. See, here we have we will get the homogeneous equation as x square y double dash minus 2xy dash plus 2y is equal to 0. So, there is the value of a is equal to minus 2 and the value of b is plus 2. Therefore, we will have the auxiliary equation as m square minus, that is equal to 3m plus 2 is equal to 0. So, we are able to find the roots, and also finally to make it to standard, to apply the MVP, we have to find new r of x. To find new r of x, we divide the entire equation with x square. So, we will have d square minus 2 by xd plus 2 by x square into y is equal to x cube by x square, the x cos x is r of x. So, new r of x is x cos x will be there. So, based on that y1 y2 and r of x is there, based on that y1 y2 we are able to evaluate the Wronskian. We can apply r of x is here and we will have r of x is here, and we are able to find the Wronskian also by using y1 and y2, and we can apply all those things into the differential the formula of yp. Then we are able to find out the value of yp. So, we will get the yp. From there we can find the general solution of the non-homogeneous Euler Cauchy differential equation by using the concept of the method of variation of parameters. There are many problems that are available in the literature of the differential equation. This is very interesting part of the differential equation. You may try to solve more and more problems in this part. Thank you for watching these videos. Continue watching. Thank you very much.